Hello, everyone, and welcome to this DevOps Twitter chat. I'm really thrilled to have with us Viktor Farcic to discuss DevOps and Docker. Thank you, Viktor, for joining us. I know this is really an area that you have a lot of expertise in. You've written one book on test-driven Java development, but also another book specifically on DevOps and using containerisation to support, the automation of continuous delivery pipeline. So thank you so much for joining us. Perhaps you could start by telling us a little bit about yourself, your background, and what you're working on at the moment.
Oh, my background is long. I'm an old man. I worked with different things, like developer, like almost everybody starting. Then I moved to systems architecture, being technical lead, back to development, everything except management. So if there is something, I did it. And currently, I'm working for Cloudbase. We are a company behind Jenkins, helping customers adopt continuous delivery, continuous deployment, and very much involved with Docker. I'm, let's say, very, very involved with the community and helping them helping us, and all those things.
Fantastic. Maybe just tell us a little bit more about Cloudbase as a company and what Cloudbase offers to your customers.
Yeah, basically we are the major contributor to open source Jenkins, and on top of that we have enterprise edition that we sell to our enterprise customers, and it's a similar model to Red Hat. You get enterprise on top of open source, and on top of that support and all those things. We make sure that it runs.
Fantastic. So it's really helping people get to grips with Jenkins and understanding how they can best use it to build their continuous integration, delivery, deployment pipelines. Wow. Sorry, go on.
No, it's kind of, it's not only like anything else. It's not only about installing the product and say, oh, I have my continuous delivery, right?
Yes.
It's a difficult part.
Yeah, and I suppose just briefly on that, because in some of the chats we've had so far, it's been amazing how much. So obviously there's tooling and there's automation, and that's an important part of it, but a lot of it is also cultural and organizational. Does that fit with your experience as well?
Oh yeah, depending on how your company culture works and how it's organized, you can do some things and you can do others. Take microservices, kind of everybody speaks about them as an example, right? If your company is monolithic, you cannot do microservices.
Yeah. So
you can try, right? You can try. You take your project, say I'm gonna do microservices, but it's gonna fail, right? The same way as if you have a lot of departments and handovers, you cannot do continuous delivery or continuous integration simply because continuous is contradictory with handovers, right?
Yes, yeah, which again fascinating, because just a few weeks ago we spoke with Joanna Rothman, and she was absolutely saying that. She said if you don't have cross-functional teams, then you end up with handovers, and with handovers you can't have fast cycle time. So it's
exactly, and it's not even necessarily. I'm not kind of radical on that opinion. It's not necessarily that you have to do microservices and you have to do continuous delivery. You just understand that if you choose to do that, then you need to change.
You need the right structure and culture to support it, as well as
exactly.
As the tooling. Yeah. So
otherwise, it's similar like in continuous integration, right? Everybody is doing it for 10 years, but actually in reality, most people are just faking it because you have a project, you think you're doing it, but your culture prevents you, and then you have Jenkins running and doing 3 builds, right?
Yes, yeah, that's right. Yeah, so I suppose you're saying it's tooling is an important part, but you've got to have the culture and the organization that in place as well to support it. And
exactly.
Yeah. So just I suppose for people who are not familiar with Docker, or perhaps don't understand why Docker has become such a phenomenon, could you give us sort of a little summary of what Docker is and why it's becoming so important?
Oh, it's quite bigger than short summary is difficult with Docker. There's so many things. It allows us quite a few important things. One of them you mentioned, self-sufficient service teams, right? It allows teams to run things wherever they want, on their laptop, on the staging environment, in production. It allows them to define a full life cycle of application, right? It allows them in a way to do continuous delivery or deployment, because without Docker, you can get up to a certain point, and then some other department infrastructure is to come in and do this and that, right? With Docker, you can define, this is my application, this is code of my application, and this is my Docker image. And when you put Docker image, it will just run, and nobody but the team who wrote that service can need to think about it much more, right? Much beyond that. And there are other things like immutability, for example. Since Docker images are unchangeable, we know that it will run exactly the same in one environment as the other, which translated to plain words means that finally you can know that what you're putting to production is what you tested, instead of testing one thing and then putting to production something slightly different and then wondering why it doesn't work, right?
This is the end to the, it worked on my machine.
Exactly.
Yeah.
It allows basically, it moves infrastructure tasks, I think, closer to teams who code. Which does not mean that we don't need infrastructure expertise. We definitely need, but the game is quite different now, I think.
So I mean, I was discussing Docker with a colleague of mine, and I was saying that. So when I first heard about it, it was one of your now colleagues. Do you know Demian Deportal, who introduced me to it? And at first, I was a bit like, I don't understand why this is any different to virtual machines, for example. And I think in my journey, if this is really getting Docker and this is not knowing about it at all, I'm probably about this far along. But is part of it as well that, so with a virtual machine, you have a big binary thing, and yes, you could write some scripts to set things up on it, but it's basically a big binary image, whereas a big part of Docker is defining what should be on that. So what the environment needs to have to run your software in a text format. Is that right?
Yeah, exactly. I mean, imagine that if you would be using virtual machines, imagine that every time you build the new release of your service, you build it by creating a completely new virtual machine with everything inside, including your service, right? Yeah. And imagine that you would have a separate virtual machine for each service that you're deploying, right? 100 services, 100 virtual machines. Mm-hmm. Now, with virtual machines, that process would be terribly slow. It would take you ages to do that. And on top of that, let's say 100 services, 100 virtual machines, that means that you have 100 OSs that are eating your resources for almost nothing.
And all of them need managing and patching, yeah.
Exactly. So it's almost as if you're having a very, very efficient way to build a new virtual machine that would be moved throughout the life cycle until it reaches production.
Yeah. Right, yeah. So, and I guess it reminds me of something Linus Torvalds said about Git and speed. Sometimes the performance improvement means you can do things in a completely different way. And I suppose that's happening here. And some people go, well, just lightweight VMs. But the point is, you would never, if you needed 100 VMs running on your developer laptop to code something, you'd never do it. But now with Docker, you can do that using containerization.
Exactly. It's precisely what you said. Kind of, it's not that really something logically prevents you from running 5 VMs on your laptop, right? But we don't do that simply because it's heavy, it's slow and stuff like that. So we have development servers running somewhere and all those things, right? But so it's what you said. You can do it with virtual machines, just if you're very, very patient and everybody has MacBooks with 100 gigabytes of RAM and all those things. No?
Yes.
Theoretically, you can do it. It's not you cannot, but in practice, it enables certain things that I don't think that we ever get a technology that makes something truly new. Mm-hmm. It's always evolution. It's just small steps, but those steps allow you to do, even they might not be so big, they allow you to do something that make practical doing something that you couldn't do before, right?
Yeah.
So, yeah, it's I mean, actually what is really revolutionary is simplicity around all that, because containers existed in Linux for 15 years or something like that, right? So it's not that we did not have containers until yesterday. It's just that almost nobody was capable of creating them without Docker. That's the difference. Simplicity is the difference, not that containers did not exist. They did.
And I suppose that's with many things, because even things like test-driven development, I think it was Kent Beck sort of started, on what became the XUnit framework in the 90s. So it's not particularly new, but the difference is now there are books like yours, there's information online, there are frameworks, there are mocking frameworks, there's so much that just makes it, the barrier to entry for using that as an approach is so much lower than it was 20 years ago, where you had to write your own framework.
Exactly. It takes, I don't know, it takes 10, 15 years until between somebody coming up with something and we adopting it. That's the time frame. 10 years approximately, something like that.
Yeah.
I mean, microservices also exist for God knows how much time. It's just that we did not use them until recently, right? Except if you're one of the 5 top companies, something like that. Same thing with containers. They existed, we did not use them. I mean, heck, virtual machines, it took VMware, like 10 years until actually that gets adopted, right? So it just takes some time. And then some other people have can go to listen to some conference and say, oh, heck, this is nothing new. It's not about being new. It's about we starting to use some.
Yes, about actually applying it in a way that's really so. I mean, that brings us nicely on, I suppose, to the topic of DevOps, and how is it that containerization and microservices, why do we see those as a way of helping teams become more DevOps?
Because they're very much, I think that they're very much interconnected, and there is a very good reason why actually we are all started speaking about microservices, for example, containers at the same time, and other things. But to begin with, I think that DevOps, Agile made a promise saying that we are going to make self-sufficient teams, right? And that was one of the premises of Agile. And then those small teams will be able to do stuff. Now, that never really happened, because those teams were self-sufficient until they finish their sprint and say, okay, this is done. You, somebody, I don't know who you are, right?
Yeah. Some
make it run in production, right? More or less. So I think that operations were excluded from that fancy new movement, Agile, right? Everybody's Agile, but then you have sysadmins sitting somewhere in a basement doing stuff nobody knows about. And I think it's about moving those people into those same teams, right? And then being part of those things and being part of that life cycle. And then once you put those people inside those teams and that knowledge inside of those teams, then you can actually do continuous delivery, because suddenly you have not only expertise how to develop your service and test it, you have expertise how to actually run it in production, kind of. And then you're fully I think that DevOps is about speed and self-sufficiency in a way, putting everybody in the same team. And then containers came, or before or after, nobody knows, everything is mixed, and allowed us to actually define infrastructure in a decentralized way, right? Every service has a full definition of what that service needs to have in order to run in production and everywhere else, right? As opposed to before, we would have Chef, Puppet, and those things, and then that's completely centralized somewhere else, and some other people need to take care of it, and then it was completely separate process, separated from development in a way, from life cycle of an application. But then on the other hand, microservices, you could technically do it, but infrastructure hell you will have with microservices without containers is just too big of a price to pay. And then once containers kicked in, then we can do microservices, because without them, let's say that, one team wants JDK 7, the other team wants JDK 8, the third team microservice wants Node.js, right? Sysadmins would go crazy with something like that. But since it's not anymore that they need to take care of infrastructure on OS level, but it's in containers, then everything can be decentralized and sent to teams, and then they're all happily producing something to production every hour.
So it allows you to have these teams that have the full skill set to develop and deploy something.
Exactly.
But still run their components, I suppose their microservices, on shared infrastructure almost. Is that right?
Yeah, it's a shared infrastructure. So you run your services together with other services made by other team, of course, and but the dependency of what those services need is decoupled one from each other, and they speak through APIs. They have everything they need to have inside of containers. So yes, they live together. We all live happily together, like humans, right? But we all know our own responsibilities, and you and me now communicate through voice, and that's the only way that we can communicate because it's online, right?
Yeah.
The same thing with services. We can happily put them to coexist simply because they have no contact except communication through API.
And is it also right that there's an aspect of this that allows you to scale as well? So perhaps on the dev machine, I could run all the microservices on my laptop for development, but in production, you might distribute those across more than one machine to scale.
Oh yeah, no, it's not. That's not the option. You run a cluster, right? Even a smaller site needs to have 2 servers, because what happens if one server dies, right? You need to have high availability and all those things, kind of. And that's one of the changes that happened relatively recently when you're talking about 5-10 years, right? That everything is scaled now. Even if you decide tomorrow to make a site about your favorite hobby, since you're a popular person, chances are that you might have thousands of visitors even for something so small, and you need to think about scale, right?
Yeah.
Everybody needs to think about scale. And that's another huge advantage about Docker, right? How do you scale non-Dockerized things without losing all your hair within the process?
I've already lost mine.
Yeah, I think I saw that you scaled a lot before. Kind of.
Yeah, this is from scaling pre-Docker.
Exactly.
So, but it's a good point as well that because this whole idea as well of only sort of building what you need now and not trying to identify all the requirements up front. And of course, if you use an architecture where scaling and resilience is something that's almost inherent, then I do think you don't need to spend lots of time working on how the application is scaled. Build it using a fairly standard scalable architecture. You can run it on one machine to begin with. I say one machine, one VM image.
Yeah.
If you need to scale, you can scale up without a sort of, as I say, without months and months of extra design effort in case you need that extra performance.
Yeah, and that's true. I mean, without extra design effort, that's true if you're talking about service-based architecture, right? Mm-hmm. If you're talking about monoliths, then that's not really true, because sooner or later you're going to realize that actually bottleneck is only part of the application, then you won't be able to speak to this. You need to take, I do think that you need to take design in account from day one, mm-hmm. architecture.
Yes.
So we need to think about architecture even for the smallest of applications. What we don't need is to build for something big mm-hmm. until that becomes big. I think that's one. I've worked with a lot of enterprises and before, like as a systems architect, software architect, and they all have that notion. I want you to design me an application that will be able to handle Google type of load, right? But today we have 100 users, right? But yes. we want you to build it in a way that it can support billions of users. And then they make a project that lasts for a year, just for and I could accomplish the same thing that they accomplished for a year, for a week, just discarding everything that they don't need. But there is that kind of, I think that many companies are still thinking in terms of, I want to build something to last. Mm-hmm, mm-hmm. And that's completely wrong. We are building something that is most likely going to be obsolete next year, right? That's how fast the industry is moving. Because if you're building something that should last for 10 years, that means that for 9 years, it's going to be obsolete. It's kind of like a waste, right?
It's just pure waste, as you say. So what I'm also really interested to hear, because you work with a wide range of companies, is what do you see, what sort of typical challenges do you see with, so people might say, great, we'd love to use Docker, but what are the challenges? What are the barriers that stop them starting to use that technology?
It's never Docker. The thing is that Docker is extremely simple, right? They're dedicated to simplicity. You can go to their site and do the tutorial, and in 2 days, you're kind of half expert. I cannot say an expert, but half expert, right? But the problem is that it's not about adding another layer on top of what we have today, right? The same thing as SOA failed before because ESBs were just another layer. Same thing with Docker. It's not just about putting whatever you have today into Docker and saying, oh, now my thing is scalable. Now I can do this and now I can do that. It's about refactoring, re-architecturing our applications to be modern. And if they're modern, then they can fit into Docker and we have a lot of benefits. Now, I'm not trying to say that you cannot fit into Docker something that is not current, something old. You can do it, but then you get 10% of benefits. But why would you bother with new technology if benefits are small, right? You want a lot of benefits, but a lot of benefits come at a cost. And cost means it's not about putting in containers, it's about changing the way how we do business, both on human level and technology. And that's the major obstacle. I cannot say the name of the company, but I had a request saying, we have our application written in COBOL and running in mainframe. Can you please put it inside of Docker? And I just walked away. I mean, why would you do that? It's not about putting things inside of containers. It's about what containers enable us to do. And they enable us to do different type of architecture and deployment and all those things.
So what sort of advice do you give in those cases then? You know, if it's not practical to move the whole application into Docker, what can a company do as a starting point?
Yeah, I think that, again, I'm talking about perfect cases. I think that microservices type of architecture is the perfect use case for Docker because things are small, and when things are small, they're easy to scale, and when they're easy to scale, they're perfect case for Docker. They can be built fast and all those things, right? So it should be small, and it's really, if you would exclude culture, it's not really that hard to start making services. It's just about the major obstacle I found actually that clashes with many cases is that if you want to go towards services, that means that you have vertically to split things, right?
Right, yeah.
So new feature is going to be a service and it's going to have everything inside and it's going to be only this. But most software, when you go there in a while, most software is built completely different. It's built vertically, right? Can we make a service that is that data access layer, right? No.
Okay.
It's not about that. It's about I would really like to recommend domain-driven design. That's a starting point. It's a very, very difficult book to read. So if you manage to read it through, you're a hero. But once you gather those concepts, that feels. I think that those three things must be combined: domain-driven design, services, and containers, and then we can get continuous deployment, right?
So it sounds to me, and I always have to be careful when I'm phrasing something back to someone, but it sounds to me like you're saying you're not going to get all the benefits if you just take a big monolithic application and stick that in a container.
Yeah.
You need to look at what part of it can you split out into a microservice, and you don't want to take the horizontals, you know, the database or the user interface. You want to try and take a feature slice almost, and your tip is domain-driven design to help you identify what a sensible boundary is, if you like, for a particular microservice. Yes.
Exactly. You need to combine things that chances are you haven't been using before. And the truth is that, you know, if you walk the street and you find something that really, really smells, I'm not supposed to say the word probably. It's not about putting it in a container and saying it's gonna stop smelling, right? and take it home. You don't do that.
No.
You throw it to the trash. You don't put it in a box and take it home, simply because. And every single company that lasts more than a couple of years has a lot of things that smell, simply because things changed, right?
Yeah.
And so yes, what you said is correct. You need to go back to beginnings, I think, and re-architecture things, and that's very expensive.
Yeah, so it's certainly an investment. It's not something you can expect to kind of in a few hours get all these benefits without actually, you know, you need to put some time into it.
Yes and no. Again, that depends on the culture of a company.
Right.
If your culture is made in a way that refactoring is your part of your daily job, right?
Mm-hmm.
Then you don't have to make a project saying we're going to modernize our system, because your system is being refactored all the time. Now the problem is that refactoring is not really a common thing among companies,
Mm-hmm.
and then they say, look, we neglected this for 10 years and now it's too expensive to change it. Yes, right.
And that's kind
I
of a
tend to
technical debt question almost, isn't it?
Yeah, I tend, among other things, I tend to tell teams that if let's say 1/3 of your time, coding time, is not dedicated to refactoring, you're not doing a good job. But everybody's kind of, we want a new feature, we want a new feature. Nobody wants to go back.
And this, I suppose this is because one of my biggest revelations was when I did some test-driven development for the first time and realized that one of the great benefits was you could refactor and you could change code with a high degree of confidence. And it just becomes the way you code your feature, go, yeah, does that now pass my new test? And then you look at the code and say, and is that the best way? Have I written it in a good way, or do I actually need to change some of that now? And it's quite straightforward if you take that approach, but very hard if you've just about managed to get everything working with no automated tests. Then you're really. Sorry, go on.
Yeah, that's the thing. Without good test coverage, you cannot improve your stuff because you don't know what's going to break, right?
Yeah.
And if you cannot improve the stuff, you cannot refactor. And if you cannot refactor, then you get smelly thing after a couple of years. And that's how it works. I mean, there are a lot of arguing kind of how to define legacy code, right? Mm-hmm. To me, legacy code is a code that is without tests.
Right.
That's the definition. Doesn't matter whether it's a month old or 10 years old. You don't have tests. It's a legacy code because you don't have ability to improve it.
That's really, I've never heard it defined like that, but I think that's a fantastic point you've made. So I'm conscious of time, Viktor. Maybe you could just finish off by, so if someone sees this and thinks, great, I'd like to get started with Docker, I'd like to do something, what would be your top tip or tips for people taking the first steps with it as a technology?
Buy my book.
That's great. That's simple. Buy Viktor's book and do everything it says.
No, it's on a serious note. I mean, if you want to start with Docker, really, Docker official site is a good starting point because it's very, very, very straightforward and simple, and you can do this. I really recommend it. Before you start thinking about how Docker works and all those things, just come up with a pet project. It can be pet project for your company. It can be pet project for yourself, whatever. Just a pet new project that will not have a lot of baggage.
Yeah.
And then say, oh, I'm going to start with Docker with this, right? Make a application that organizes photos of your girlfriends or whatever, right? And then start. Don't start with Docker by trying to fit it into your existing application. That's my recommendation.
So you start with something fresh so that you can learn and understand it before you try and apply it to like a business critical system that you're working on. Yeah.
Exactly.
Okay, fantastic. Right, it's been really interesting. As I always do, I've learned a lot just from 20 minutes with you, Viktor. So it's been awesome for me. Really looking forward to the Twitter chat as well. I'm sure we'll have fun. So yeah, thank you again, and see you soon.
Thank you. See you soon. It was a pleasure.